Good morning, children. And today in this session we are going to discuss the new things about a pair of linear equations in two variables. See here, in my last session we discussed about a pair of linear equations in standard form, and if their graphs are plotted, what is the condition to get the intersecting graphs, to get the coinciding graphs, and to get the parallel graphs? That we have discussed. And today we will discuss that what do we mean by common solution or common solutions of a pair of linear equations in two variables. And we will also learn one more condition for the graphs of pairs of linear equations in two variables to have intersecting graphs, to have coinciding graphs, and to have parallel graphs. Okay? See here, 2x plus 3y plus 5 is equal to 0 is one linear equation in two variables, and 3x minus 2y minus 12 is equal to 0 is one more linear equation in two variables. Thus, these two equations are forming a pair of linear equations in two variables. See here, children, today we will learn what do we mean by common solution of both the equations. See here, if I find the solutions of this equation, how many solutions it has? It has infinitely many solutions, but I have listed 5 solutions here. These are the solutions of this equation. If I find the solutions for this equation, how many solutions I will find? I will find infinitely many solutions. But today let us learn how to find the common solutions for both the equations and what is the meaning of common solution or solutions of both the equations. See here, 0 comma minus 5 by 3 is solution of this equation. This is not the solution of this equation. And minus 1 comma minus 1 is solution of this equation. It is not the solution of this equation. Similarly, if I take 0 comma minus 6, this is the solution of this equation, but not, 0 comma minus 6 is the solution of this equation. This is not the solution of this equation. If I take 4 comma 0, this is the solution of this equation. This is not the solution of this equation. But you see that 2 comma minus 3 is solution of this equation also. 2 comma minus 3 is solution of this equation also. That is why 2 comma minus 3 is called the common solution of both the equations. Means common solution of a pair of linear equations. Do you understand? If you put this 2 comma minus 3 here, left hand side becomes equal to right hand side. The same 2 comma minus 3 for x and y, if you put here, left hand side becomes equal to right hand side. But if you put 0 comma minus 6 here, LHS becomes to RHS for this equation. But if you put 0 comma minus 6 for this equation, here LHS does not become equal to this equation. That is why 0 comma minus 6 is not the common solution. It is solution for only this equation. If you take minus 1 comma minus 1, this is the solution of this equation. Put x is equal to minus 1, y is equal to minus 1 here. Left hand side becomes to right hand side here. But if you put minus 1 comma minus 1 here, this equation will not become equal, LHS will not become equal to RHS here. That is why minus 1 comma minus 1 is the solution of only this equation. It is not the solution of this equation. Whereas 2 comma minus 3 is the common solution of both the equations. This is the meaning of the common solution of a pair of linear equations in two variables. So, what do you mean by a common solution of a linear equation in two variables? It is that value of variables x and y, if substituted in both the equations, then both the equations are satisfied for that value of x and y. On the other hand, the LHS of this equation becomes equal to RHS, and the LHS of this equation also becomes equal to RHS for that particular value of x and y. So that value of xy is called the common solution of both the equations. Okay, students, if we take one more pair of examples here, pair of linear equations in two variables, and I find 5 solutions here for x is equal to 1, minus 1, 0, 2 and minus 2. Okay, then the corresponding values of y's are minus 2 by 3, minus 4 by 3, 8 by 3 and 0. Then for this equation I take the same values, x is equal to 1, minus 1, 0, 2, minus 2, and the corresponding values of y's are minus 2 by 3, minus 4 by 3, 8 by 3 and 0. See here, for x is equal to 1, y is equal to minus 2. Here also for x is equal to 1, y is equal to minus 2. For x is equal to minus 1, y is equal to minus 2 by 3 in this equation. Here also for x is equal to minus 1, y is equal to minus 2 by 3 for this equation. Similarly, for x is equal to 0, minus 4 by 3. Here also for x is equal to 0, minus 4 by 3. For x is equal to minus 2 comma 0. Here also for x is equal to minus 2, y is equal to 0. It means how many common solutions are there for these two equations? Whatever the solutions of these equations are there, they are the solutions of this equation also. Whatever the solutions of these equations are there, they are the solutions for this equation also. So now we understand that these two equations have infinitely many common solutions. Means whatever the solutions of these equations are put for this equation, here LHS becomes equal to RHS, and whatever the solution of this equation has, if those solutions are put for x and y for this equation, here also left hand side becomes equal to right hand side. It means every solution of this equation is also a solution of this equation. Thus both the equations have infinitely many common solutions. Okay, and now let us come to the third example. Both form a linear equations in two variables. Okay, now you see, I have taken 3x plus 2y minus 4 is equal to 0 and found its 5 solutions for x is equal to 0, 1, minus 1, 2 and minus 2, and have got the corresponding values of y as 2, 1 by 2, 7 by 2, minus 1 and 5. See here, for x is equal to 0, 1, minus 1, 2 and 2, minus 2. Here for this equation also, I take the values of x as 0, 1, minus 1, 2 and minus 2. Here also x values are same, here also x values are same, but the corresponding value of y for x is equal to 0 is 2 here. Here the corresponding value of y for x is equal to 0 is 9 by 4. Right? For x is equal to 1, here y is 1 by 2. For x is equal to 1, here y is 15 by 4. For x is equal to minus 1, y is 7 by 2. For x is equal to minus 1, y is minus 3 by 4 and so on. Here, when we compare the solutions of these two equations, we find that there are no common solutions for both the equations. If you take 0, 9 by 4 and put here, only this equation is satisfied. If you put 0, 9 by 4 here, this equation is not satisfied. That is why 0, 9 by 4 is the solution of only this equation. That is not the solution of this equation. If you take 2, minus 1 and put here for x and y, only this equation is satisfied. LHS becomes equal to RHS. Whereas if you put a 2, minus 1 here, the equation is not satisfied and LHS is not equal to RHS here. That's why I say 2, minus 1 is not the solution of this equation, that is only the solution of this equation, and it has infinitely many solutions. It has also infinitely many solutions. If we continue, we find that there is no common solution to both the equations. Okay. So, this is what we have learned about the meaning of common solutions or common solution to a pair of linear equations in two variables. Now children, what we are going to learn next is how to find this common solution for a pair of linear equations in two variables. That we are going to discuss now. See here, to find the common solution to a given pair of linear equations in two variables, there are mainly two methods: graphical method and algebraic method. Okay. In graphical method, we plot their graphs and then find the common solution. In algebraic method, we use three methods. They are substitution method, elimination method, and cross multiplication method. But in today's section, I am going to discuss to find the common solution to both the equations by graphical method. See here, take the equation, solve it for y or equate it for y, and find 3 to 5 solutions. For this equation also, equate it for y and find 3 to 5 solutions. Plot their graphs. That time, if you observe that both the graphs intersect at a point, then from that point draw a perpendicular to x-axis. The perpendicular x-axis intersects it at 2, 0, right? And draw a perpendicular to y-axis from this point of intersection. This point intersects y-axis at 0, -3. Okay. Here, this is the x coordinate of 2, 0, and this is the y coordinate of 0, -3. You have to take this as x value and this -3 as y value. And what are the coordinates of this point of intersection? 2, -3. Here 2 is the x coordinate of this point of intersection and -3 is the y coordinate of this point of intersection. Take that 2, -3 and put them for x and y here in this equation and evaluate. You will find that left hand side equal to right hand side. That is why 2, -3 is solution of this. And take the same value of 2, -3 and substitute here, and you will get LHS is equal to RHS. Okay. Here what we learned is, when the graphs are plotted, if the graphs intersect at one point, from that point you plot the perpendicular to x-axis and y-axis, and the x coordinate of this point is 2 and y coordinate of this point is -3. On the other hand, the coordinates of the point of intersections are 2, -3, and this 2, -3 is the one common solution for both the equations. Do you know why? Every solution is a point on the graph, and every point on the graph is solution of this equation. Okay. Here, this point is on both the graphs. That is why the x coordinate and y coordinate of this point are the make one solution of this equation and this equation. Thus 2, -3 is the common point to both the graphs. That's why 2, -3 is the common solution to both the equations. Okay. This is how by graphical method we find a common solution to a pair of linear equations in two variables. Dear children, here if you get the intersecting graphs, okay, then the equations will have only one common solution. which is called unique solution. Okay, if there is a unique solution, the graphs will intersect once. Do you understand? The condition for a pair of linear equations and to plot its graphs and get the intersecting graphs is one more condition. That is, if both equations have only one common solution, then the graphs will be intersecting graphs. If the graphs are intersecting, you should think that both the equations have only one common solution. Okay. Now you see, one more pair of linear equations. To plot the graphs, we will find the solutions of this equation and solutions of this equation. And after finding the solutions, we plotted the graph, and the graphs are coinciding here. The graphs are coinciding here. See, every solution of this equation is also a solution of this graph, and that's why the graphs are coinciding graphs. Okay, every point on this graph is common to both the graphs. That is why every solution is common to both the equations. Okay, here both have infinitely many common solutions. Therefore, every solution is a point on the graph, and every point on the graph is a solution to both the equations. So, when the graphs coincide, the equations will have infinitely many common solutions. If the given equations have infinitely many common solutions, the graphs will coincide. If the graphs coincide, the equations will have infinitely many common solutions. Therefore, this is one more condition for the graphs to be coinciding. What is that condition? If solution of one equation is also a solution of another equation, then the graphs will be coinciding graphs. If the graphs are coinciding, then what happens? Then both the equations will have infinitely many common solutions, right? Now, let us come to the third example. 3x plus 2y minus 4 is equal to 0 and 6x plus 4y plus 9 is equal to 0 forms a pair of linear equations in two variables. Okay, these are the solutions. These are the solutions of this equation. When we compare, we are seeing that there are no common solutions to both the equations, right? If we plot the graphs are parallel. Means every solution is a point on this graph, and every solution of this equation is a point on this graph. There are no common points of intersection to both the graphs. So we decide, when the graphs are parallel, there are no common points. Therefore, there are no common solutions to both the equations. Is it clear? So, the condition to get parallel graphs is, if two equations have no common solutions, then the graphs are parallel. If the graphs are parallel, then the two equations have no common solutions. Is it clear? So, children, in this section, we learned about what is a common solution to both the pair of linear equations, and to get the common solutions, what methods are to be followed. And today we learned the graphical method of obtaining a pair of the common solution to both the equations. See here, if the graphs intersect, only one common solution, what we call as unique solution, because that point lies on both the graph. If the graphs coincide, then we decide that both the graphs have infinitely many common solutions. And if the graphs are parallel, then we decide that both the equations have no common solutions. Means there is no such value of x and y which can satisfy both the equations. Is it clear? And tomorrow I will come with one more method of obtaining the common solution or solutions to a pair of linear equations in two variables. Thank you for watching me. See you tomorrow. Goodbye.